Hi everyone, this will be a video on singly linked list for my X280 IA application. Okay, so I found this question on LeetCode. We have a singly linked list, not exactly like the one that we have in X280. It has a value and a next pointer, and then we have like three kind of constructor, but we don't really have to use a constructor, at least in my approach. Okay. So we don't have the function like add node, or we don't even have a head pointer of iterator that to keep track of the head of the linked list. Okay, so we might need to create one in our solution later. Okay, so what is the problem about? So we have to partition it. We are given a pointer to the head of the linked list and an integer x. So we need to partition it such that all the nodes that are less than x comes before the nodes that are greater or equal to x. So what it means, and also we have to preserve the original relative order. So for example, 4 comes before 3 in the original linked list, and then after we partition it, 4 must still be before 3. Okay. So in this example here, the x is 3. So 4, 3, and 5 are all greater or equal to 3. They should come after 1, 2, and 2, which are smaller than 3. Okay, so what should we do? Let's do some drawing. Oops, and before that, I think I want this over here. Okay, let me just copy this example here. 3, then 2, 5, 2. Unfortunately, I have to use pen. It's pretty annoying. Okay. So and then we have a head pointer to the head of the original linked list, and then we have x equals to 3. Okay. So the idea is, at least my idea is to create two linked lists. One linked list have all the nodes that are smaller than 3, and the other linked list has all the nodes that are greater or equal to 3, and then I combine them together. Okay, so let's see how it works. And keep in mind that we don't have in our linked list structure, we don't have an iterator to keep track of the head pointer, so we need to be very careful about it. So the way I think it will work is we should create let's say we call it the left linked list and the right linked list. So the head of the left linked list will be our new head. So we're gonna return this new head at the end of the function. Okay, and then I'm gonna call this the first node in right to be the one in the middle. Okay, and then we have a left pointer and also a right pointer, which we have to update as we add in node into this left and right linked list. Okay, so we have to iterate through the original linked list using this pointer called head. Okay, so first head is pointing at 1, 1 is less than 3, so we put it to the left linked list, we put it here, and then we're gonna update our left pointer, and then we're gonna update our head pointer. Okay, and then now we look at 4 is greater or equal to 3, so we put it in the second linked list, update our right pointer, update our head pointer. And then 3 is greater or equal to 3, we put it in the second linked list, update the right pointer, update the head pointer. 2 is less than 3, we put it in the first linked list, update the left pointer, and then update the head pointer. And then 5 is greater or equal to 3, we put it here, update the right pointer, and update the head pointer. 2, we put it here, update your left pointer, and then we don't have to do anything with head pointer. Actually, yeah, you can like put it here, but it will be now anyway. Okay. And this is not the end yet. We have to combine the two linked lists. Basically, we're gonna link this to this. This is why we need to keep track of this, because as you can see, our right pointer is now at the end already. Okay, so we need to somehow keep track of this middle position. Not only that, we have to end this new linked list by just simply setting this to null. Get the next of the last node to be null. All right, seems like we have a good idea. So let's write some pseudocode. So while we need to like loop through the original linked list, okay, and then let's say we create a bunch of things that we have that we need, like the left, right, mid, new head, or whatever. So if it is smaller than 3, then we put in this left list, and then we're gonna move our left pointer, then else put in right, and then move right. Okay, and then we have to move our head pointer regardless of whether we put them in left or right. And then we're gonna run out of space. We're gonna need to combine the two, right? So we're gonna need to combine the two, combine, and then we're gonna set let's say we call it like right, because right is now pointing at the last node, next to be now pointer. Okay, and don't forget that we have to return the new head, sorry, to return the new head. All right, you just have to write this code. I'm gonna put this side by side. Let's see. Okay, so now we have to create a bunch of things, the left, right, and this new head. Yeah, we also need this new head to keep track, right? Because our left pointer is moving, so we need to like keep track of where is our new head, and also this middle position. Let's try to do that. This node will be a pointer of left. It will be a new list node. We just have to use the default constructor. It doesn't really matter. And then we also need right to be a new list node. So I'm creating like the left and right list that we need. Okay. And to keep track of those, I'm gonna create these two pointer. Let's say we call it new head to be left. Okay. Before we change it to anything else, we just set it first. Okay. So and don't modify new head. Don't modify this. Let's say we call it what we call it again? Mid. Pre-mid to be right. Okay. So before we do anything to left and right. And now, like I said, we want to iterate through the original linked list. Where's our pseudocode? Let's see, where's our pseudocode is over here. Okay. The simplest way to look through it is to see while head, while it is not actually while head will work because we will update our head within the loop, and then as long as it is not null pointer, we just keep forwarding. Okay, so if the value at this head is less than x, okay, I should have written x in my still code. Okay, what should we do? We want to put in the left list. Okay, so what we do here is to put left okay, because we don't have the append function, we don't have the add node function. So the only way that we could add node to the list is to put it as the next. Okay, so I'm gonna do this. Next will be head. Okay, I'm gonna assign this head to the this left dot head next. Okay, and I need to what? I need to move my left pointer. So left will be left dot next. Okay. And then similarly, if it is greater or equals to x, then we assign right dot next to be head, and then update my right next. Okay. What's next? We need to move head. Okay, we need to move head. So it will be just simply head equals to head next. Okay. And okay, this will be within the while loop. After you are done with putting into left and right, we need to combine the two, right? So now your left pointer is at the last node of your left linked list. So we just have to set the next of this node to be the first node in the right linked list, right? Okay. So now left next will be okay. So remember, because we use this middle pointer to point to a node before, it's like a dummy node before 4. So we have to do mid dot next so that it actually points to 4. All right. And then we need to end this new linked list by setting right dot next to be null pointer. All right. And then don't forget that we need to return the new head. So return new head. And this should be it. Let's run it. And let's see. Okay, missing braces. Okay, here we go. Okay, you see, I made the mistake that I just mentioned because new head, it's pointing at a dummy pointer, dummy node. So we have to return new head dot next instead, which will return 1. Okay, it's okay. It's okay. It's okay to make some mistake. And yeah, here we go. Thank you.